What brought about the decision to have this vehicle for cislunar space?
Our initial intention was to build a tourist spacecraft for operation in low Earth orbit. We were looking at the approximately 100 people that'll fly as tourists, more if the price comes down. But we also looked at taking tourists to the moon because our spacecraft is capable of that. We were surprised to find out from our studies with a very good corporation to do these economic studies that the market is really for lunar travel. It's not for travel to low Earth orbit. The low Earth orbit travel is for a government space station and really does require a government contract.
Now, with the cycler type of space station that you mentioned, if other vehicles such as the Orion or future vehicles that might be qualified for that sort of travel, would they be responsible for an interstage in order to dock to the station, or would you try to enable that from the get-go?
No, that's a very good question. Our station spacecraft that travels between low Earth orbit and the moon is a piece of infrastructure. It's like a bus. It's about the size of a big intercity bus. And we're in the business of chartering it to anybody that wants to use it. They simply have to have an adaptable docking ring to dock with the station. Now, we're in the business of taking and selling transportation and logistics support and the use of scientific and technical equipment. Anyone who wishes to buy this that can get up to dock with the station is welcome to lease it. In that case, they'd be responsible for operating it. We do expect their spacecraft would have to fly to rendezvous and dock with our station.
What sort of velocity would they need to achieve in order to reach the cycler station?
In our initial mission, our first mission to go to the moon, the rendezvous and docking occurs in low Earth orbit at 18,000 miles an hour, Mach 25. It is virtually identical to the task of docking with the International Space Station. We may even use the same docking mechanisms as the ISS. At some point, when we put our station spacecraft into routine orbit between the Earth and the Moon, we will not slow down as we go by the Earth and we'll be going 25,000 miles an hour. So it'll be necessary for anybody who docks with us to boost up to that translunar velocity to rendezvous and dock. This is all very speculative because we can continue to fly low Earth orbit to moon missions if we need to. We have a lot of different options.
That would create a very small launch window, I'm sure.
Actually, that's not the case. It does not create a small launch window to do a translunar insertion, rendezvous, and docking, because you accelerate the passenger-carrying spacecraft up to translunar velocity. So the spacecraft actually is then capable of making the trip all the way to the moon, and it has as much time as it needs to rendezvous with our station. It isn't the same type of multiple orbit phasing that you do when you're in orbit around the Earth. It's more like you have a small lunar mission, but if you can dock with our station, you have a great big apartment that you can live in while you do it.
Are there any sort of future plans to, if there's any sort of other hardware out there, such as the Russian commercial space station or even Bigelow space stations, to have any sort of hub modules to connect them together to create an even larger space station?
We've looked at putting a hub module, a 6-place docking adapter, on one of our docking nodes. We have 2 docking nodes on the Excalibur Almaz station spacecraft. We can do that. The nodes exist, but at this time we think that the 2 docking ports that we have on the spacecraft are adequate. We would be very happy to use our Earth surface to low Earth orbit capsule, reusable return vehicle, to go to anybody's space station. Mr. Bigelow's, NASA's, Chinese station, anybody's station. It would just be a matter of contract.
How many more of these capsules exist in Russia? You mentioned in your presentation that you have purchased 4 already, but how many more capsules exist before more would need to be?
Well, we own 4 reusable return vehicles, and these capsules hold 3 people. We're, of course, capable of buying more of them. There are several more that are available. But I think that we'll probably build a 6-person capsule. Rather, we can do 40 trips to low Earth orbit in the capsules we have. So by the time we get finished using up these capsules, we're going to want to take more people on each flight because the rockets cost so much.
What sort of planning would need to go into upgrading it to a 6-person vehicle, and who might be the contractor to build it?
Well, our spacecraft, the Excalibur Almaz reusable return vehicle, was designed originally to be a 6-person spacecraft. And then it was, for test purposes, cut down to a 3-person spacecraft. So all we're doing is going back to the original design. It's the same mold line, the same aerodynamics. We don't have to change our emergency abort system. The emergency abort system that we have now will work perfectly well on the 6-person spacecraft. We're between preliminary design review and critical design review in the engineering for it, or I should say our Russian contractor is. If we build it in Russia, it'll almost certainly be built by the Khrunichev factory that builds all the modules for the space station and builds the Proton rocket. They're immensely capable and have a tremendously enviable technical heritage. If we build it in Europe, we'll probably have it built by Astrium. It could also be built by Mitsubishi. It could be built by Boeing or Lockheed. The design, however, would be from the NPO Machinistроения, our subcontractor in Russia, and they'd have to be involved with building the capsule.
Now, do they still have the design plans, or have they handed any of those over to you?
Machinistроения has given us thousands of pages of technical documentation on our spacecraft. We've had to have these because we had to work with them to generate interface control drawings and interface control specifications between their equipment and the Western equipment that will mount on board the capsule, like the radios and guidance and control equipment, the life support equipment. But the critical equipment for human safety, the parachutes, the rocket engines that move the capsule around, the emergency escape system that keeps it safe if there's an accident, all of those will be built in Russia, and they're capable of being produced right now. We have all of the engineering documentation drawings, or our subcontractor has them.